thank you for inviting me to this valedictory function of ROWS 2020. Let me start by congratulating Professor Shankaraman and all the faculty and students of the Optoelectronics Department of University of Kerala on holding ROWS 2020. I looked through some of the speakers and it's one of the best I have seen. So congratulations to all of you. And let me also congratulate Professor Mahadhavan Pillai, the Vice Chancellor, and the entire faculty, staff, student of University of Kerala. Getting 23rd rank in NIRF is actually a significant achievement. But as the Vice Chancellor said, there is opportunity now to actually rise above this and become one of the best in India, or maybe one of the best in the world itself. And I strongly feel that we can indeed do that. So let me also thank you for giving me this opportunity to share my thoughts in this regard. And I'm going to share with you, of course, the technology in the fourth industrial revolution. And the reason for presenting this to you is to actually talk about the opportunity that it presents to us in India, and an opportunity not just in business, in industry, but in research also. If in India we want to actually become one of the largest economies in the world, one of the most advanced nations in the world, it will have to be led by science. It will have to be led by research, innovation, entrepreneurship. I completely believe in this, and that is the reason why after I stepped down from INFOSYS, I have been supporting science, I've been supporting research, I've been supporting innovation and entrepreneurship. And that is going to be the underlying message in my talk. Right. Now, I'm going to start with a quotation of Geetanjali Rao. She was recognized as the Time Kid of the Year 2020. She's 15. But what fascinated me was, she actually compares scientists with superheroes. See, in our minds, superheroes can jump tall buildings, have technological gadgets and superpowers. But what do they have in common? The ability to save lives. And the magical thing is that they show up exactly at the right time to save a life. How are living, breathing scientists different from the superheroes in comics? No matter where they are, scientists come up with solutions to help people. I love science and I want to be a scientist superhero, solving real world problems and saving lives. And this is my salute to all the people here who are dedicating their life to become scientists. And I found this quote to be very, very appropriate. They are the superheroes. We are in a pandemic situation, and we have approximately, I think, 8 or 9 vaccines which are in the pipeline now. 3 are going to be released for public use pretty soon. And in India also, we have 2 or 3 candidates for vaccine which are developed in India. All this is only possible through the science and the scientists working very hard to make this happen in such a short period of time. Normally, vaccines take typically 3 to 5 years, but we have compressed that time frame. What would have taken 3 to 5 years has been compressed to less than a year, and that's truly amazing. And that's what is reflected in what Geeta Rao, I'm told she's called, as actually well articulated in this quote. And if children think that this is a great profession to enter, the scientists are superheroes, I believe that many children will make science as a career. Now, second, I want to actually share with you the quote by our Honorable Minister, Sri Harshvardhan. In a written reply in Lok Sabha, he said some of these accomplishments from India have directly contributed to the detection and are predominantly cited in the discovery publication. He's talking about the LIGO project, which actually proved that gravity waves indeed exist, and we were able to experimentally prove gravity waves. What is fascinating is that this is a collaboration across many different laboratories in India, and there are 3 from IISER, Thiruvananthapuram, and probably if I go across, the different institutes that were part of this, Chennai Mathematical Institute, TIFR, IISER, Calcutta, etc. There probably are people who have graduated from Kerala in that also. I'm actually a product of Kerala. I studied at Model School, Arts College, and University College, a proud alumni of University College and Kerala University. And when I see this, I feel that we are as good as the best or better, and we should be proud of what we have achieved, and we need to see more and more of such achievements in the future. I believe that we can do that. I talked about science in COVID times. It's unprecedented, the collaboration between industry, academia, government, the global collaboration that we are seeing, the race to understand the virus, the race to find cures and vaccine. And we saw science at speed. The reason I say this is, there is a sense of urgency, but how can we get this sense of urgency always? And we need to do this because, if India needs to progress, if as scientists we need to actually progress further in rankings, etc., there has to be a sense of urgency, and we need to work very hard with a purpose to actually achieve our goals, be it in rankings, be it in discovery, invention, be it in any goal that we set for ourselves. It has to happen with this sense of urgency. We don't need a crisis to create that sense of urgency. We must self-motivate ourselves. We must motivate as a group, as a team. And I feel that if we do that, there is nothing that we cannot achieve. ISRO has a significant presence in Thiruvananthapuram, and you can see that ISRO is one of the 4 in the world that has landed on moon, etc. And again, it just shows that if we set our mind to something, we are able to achieve this. The future is not a linear extrapolation of the past. Future is created integrating past experiences, inventions, and innovations till today and current circumstances. Future is influenced by leaders. Scientists are leaders, actually. They discover something. In the field of science, the leaders are the scientists. So, if innovations and inventions are going to create the future, then scientists have to have an important role. They are the people who are going to actually play an important role in creating. Of course, entrepreneurs who take the science from the lab to market also play an important role. And a crisis sometimes also allows us to change leadership. And I'll come back to this theme again and again, because this is what I have learned in my professional life. This is what I have learned. Very short introduction. I'll come back to this again. INFOSYS, and when I joined the computer science profession in 1979, personal computers were just introduced, and it started the democratization of computing. What I mean by this is computers were accessible to individuals, and today and it is accessible to everybody. And we will see this democratization, move to pervasive computing, invisible computing, computing everywhere. And what we saw was, with the introduction of personal computer, we saw that business processes that hitherto were done manually were going to be automated using computers and software, which means large amount of software will have to be written. We said, why can't we leverage the professionals in India? India is a lower cost economy, so we can actually deliver this with very high quality at lower cost, leveraging, of course, technology to connect the client to our development centers. That came much later. When we started INFOSYS, the data communication capabilities were not affordable. They were existing, and the bandwidth was not sufficient. But we anticipated that in some sense, and we were able to create a successful IT services business out of India on these above principles, actually. And that industry is fairly large industry today, and I'll come back to this. But that's what gives me the confidence to say that we can, take advantage of these technology changes, these disruptions. We can create world-class industry out of India. So I will now step back and take you through the lessons learned in the third industrial revolution, and I have a reason for doing this, actually. So many of you are probably familiar with this. Alan Turing postulated the Turing algorithm, where he said that you can actually take any algorithm. An algorithm is a series of steps which can be depicted using a state transition diagram. And then if you have a tape which has the input, this input will be converted into an output using these algorithms. The state transition machine will actually convert this into an output. And this universal Turing machine said that any problem actually can be converted into a series of steps and be solved using the universal Turing machine, which is the basis for the digital computer, right? And the second basis for the digital computer, I believe, is what von Neumann came up with, which is the von Neumann architecture, which is nothing but you store the program and the data in the random access memory. They share the same memory space. And of course, that's again simplified the computing. Now you can actually create an algorithm, take an algorithm, program it, store it into a computer's memory, and the central processing unit then accesses it step by step and execute these steps, which is what Turing also postulated. But now we have a physical implementation of this. And this is the genesis of digital computing. Some simple ideas like this created the digital computing industry. But of course, there's a lot of science and technology underneath that. So if you look at the progression of digital computing, and this is what invention, etc., is all about. When I started in the computer industry, the mainframe computers, occupying more than a floor and things like that, was how computing was done, accessible to very few people, actually. Then when I joined Padma Computers, I started working on the data general computer, which is called a mini computer. It also brought time sharing, accessible to more number of people. This is what changed how businesses use computing. Then you see the personal computer there, which is what IBM introduced in 1981. Apple introduced the personal computer in 1977. Then you see a series of photographs of mobile phones, actually, how mobile phones have evolved, and to the current generation, which is all about apps and things like that, which is popularized by Apple computing. So you can see that how computing has evolved to go from very few people to almost everybody in the world. It's about 4 billion people having access to computing, etc., today, using their mobile phones. It has completely transformed our lives. And in the future, we are looking at computers everywhere, pervasive computing, computing in healthcare through wearable devices, devices which you can actually inject into the body, in retail, point of sale and things like that, in consumer, home speakers and things like that, having computers, lights having computers. Every aspect of our life is going to get actually transformed through IoT and things like that. And all of this will use computers. And so from today's 5-6 billion mobile devices, we are going to see 50 to 60 billion internet connected IoT devices. And that's why I said computing everywhere. And that's going to completely transform how we think about the impact of digital computing, because what does computer allow you to do? It allows you to send instructions and control something, manage something. And once you are able to control and manage something, you can actually load programs onto that and let it actually run on its own. But it's still running a program. And you need to understand the problem. You need to convert that solution into an algorithm, into a program, load it into a digital computer, and let it run. That's the current paradigm. But that paradigm has completely transformed our lives and every aspect of our life. And this has created a $5 trillion global industry. See, this is the relationship between what happens in the lab, what happens in science by people like you, and how it gets translated into economic development and things like that. The global economy today is about $80 trillion. And 5 trillion of that is directly attributable to the computing, digital computing, and the telecom industry today. And that's the impact. And just one company, Apple, has become a $2 trillion company in market cap. And in the NASDAQ 100, the top 5 companies are all IT companies. Apple, Microsoft, Amazon, Alphabet, and Facebook are all IT companies, actually. And what is even more interesting is that all these 5 companies didn't exist 50 years back. That is, in our lifetime, these companies have become the major contributors for wealth in the world, in the US and China and things like that. And it has completely transformed our lives. And it only took 50 years. Digital computer was, of course, introduced in 1945, but in a 75-year period, 85-year period, 80-year period, we have completely transformed the world through the introduction of digital computing. Its impact is really, really massive, actually. Of course, I was part of the IT industry in India. Today, it's a $190 billion industry, and that itself is about 8% of India's GDP. So I, was able to contribute also to this, actually. So again, what I wanted to say was, we can change lives, we can transform lives. Now, let me also share one more data point with you, which is even more fascinating. This is the global GDP growth over the last 200 years, right? And the blue line is US. And what's the blue line? Till the 1900, they were significantly lower than the green line, which is Europe. Europe was dominating the world in the 1900s, actually. And US was nowhere, well, I can't say nowhere, but it was significantly smaller than that. 200 years back, US was about 2% of the global economy. Now, in the 20th century, so 1900 to 2000, 100-year period, in the 100-year period, US has become the largest economy in the world. Now, how did that happen? It happened on top of 2 industrial revolutions. One is the second industrial revolution, which is factory automation and things like that. And in the second half of the 20th century, they rode on the digital computing revolution. Clearly, these things can actually transform even countries. They can transform countries, they can transform businesses and industries, and they can actually create enormous wealth for individuals, people. And that's the impact of research, innovation, entrepreneurship. And that's why we need to create a robust ecosystem for research, our own knowledge, our own products and services, and we must invest in taking that research from the laboratory to the consumers, to the market. Sometimes it takes a long period of time. You cannot predict. Research is open-ended. You cannot predict when that research will get applied, but it will get applied, and it will get applied in ways in which we probably will not be able to predict even today. I again go back to the LIGO project. Einstein actually wrote the theory on gravitational waves 100 years back, and it took 100 years for experimental proof for existence of gravitational waves. 100 years, because the technology, the engineering required to detect such a small perturbation was not ready yet. So it takes probably hundreds of years, and that's the march of science. And we need to invest in basic science, basic research. We need to invest in applied research. We need to invest in entrepreneurs and grow the economy. Now let me come to the fourth industrial revolution. So I am, and many of the older people in this listening to this are part of the third industrial revolution, and the students who are here are part of the fourth industrial revolution, and they can transform the world. They can transform India. They can create new industries. They can come out with new science, and I will talk about that now. And I will talk about a couple of technologies. See, I talked about the digital computer as one technology, but digital computer is today used in everything that you do. In your labs, digital computer is used. If you're doing physics, chemistry, biology, anything that you do, you're using digital computers. These are tools that are horizontal tools that are used across. And these are the tools that have the ability to transform all walks of life, every human endeavor, every thing that we do, etc. And these are the ones which will have significant impact in the world going forward. So now let's look at the fourth industrial revolution, and you will see, of course, computing, smartphones, IoT, they still have a long way to go, and computers will have a long way to go, because there are now new techniques that you can use in computing, right? But look at other things that are happening. Connectivity is improving with 5G. We are going to have new ways of visualization through augmented reality, virtual reality. Robotics is going to change many walks of life, including, older people now have robotic companions actually. Blockchain is a way to look at secure contracts and things like that. Cloud computing infrastructure is centralizing computing again. We went from centralized processing to decentralized processing and back to centralized processing. Big data, the explosion of data is giving us opportunities to leverage this data for new purposes and things like that, to come out with new inferences, etc. Quantum computing potentially will change the way we look at computers themselves. Better materials, 3D printing, create new ways of creating even physical objects, organs, etc. AL and ML, and I'll come back to this actually. AL, ML is a fundamental tool, again, like digital computer. Genetics and code of life, again, DNA sequencing and things like that. And if you look at the mRNA vaccine today, it's actually an outcome of our ability to actually manipulate RNA, DNA, etc. in the lab. We can create life in the lab, and that's again a significant advance in what we can do. And I will come back to this because we are at the cusp of something probably something unprecedented today. And the whole of this is called the fourth industrial revolution. And the fourth industrial revolution is important because of AI and ML, I believe. See, the traditional model of computing, which we all learned, is you have an algorithm which is converted into a program, you feed in the data, and out comes the result. But you need to know how to solve the problem first. And that's why business processes were automated. What we used to do with manually got automated because we know how to do things. But the new paradigm for computing is that you feed the results, you feed test data, these are labeled data, and out comes the algorithm. You are actually creating the program using the computer, same computer, which means that you don't need to know the algorithm, you're training. And that's the key word. You're training just like you train people, you train children how to solve the problem. And then they know how to solve the problem afterwards, actually. Though they may not be able to explain this anymore. And that's how our brain works, right? We don't know how to explain certain things. How do we recognize faces? How do we see a pattern, right? Things like that we will not be able to explain. And that's what we are now equipping our computers to do. So suddenly we are able to actually create solve new classes of problems. Facial recognition, automated cars and things like that, self-driving cars, security using cameras and things like that, speech recognition, natural language processing, real-time translation, intelligent personal assistance. When you call Alexa and things like that, it actually answers to your questions and things like that. This is intelligence revolution, and slowly we are embedding intelligence into everything that we see around us, ambient intelligence around us. Just like we had invisible computing around us, we have now ambient intelligence. Everything that we see will have intelligence. It will be able to respond, and it will be able to sense and respond automatically without human intervention at all. Human intervention is not necessary. And I also believe that artificial general intelligence in some form or other is possible. That is because humans have endeavored to actually mimic nature forever. And I strongly believe that nature as an engineer is underestimated, because nature is probably the best engineer in the world. Amazing, actually, how nature has done things. And nature has had billions of years to learn. And that's the beauty of nature, actually. And anytime we have tried to mimic nature, humans have actually exceeded nature in mimicking itself. So moving from place A to place B, walking, running, using animals, using bullock carts and things like that. Then we invented automobile, then we looked at planes, rockets and things like that. Today we can go from here to the moon. We can go from here to the Mars. We can go from one end of the world to the other end of the world within a very short period of time and carry multiple people. This is why I said we can mimic nature, but far exceed nature in things that we endeavor to do. In computing itself, as humans, we will be able to do, let's say, I don't know, the best people will be able to do 100 computations per minute. I don't know, maybe we can do. But computers can do billions of computations, billions of computations in a minute, actually. So when we replicate, we don't replicate exactly the same way we do things. We actually figure out with the technology that we have, with the engineering that we have, with the science that we have, with throwing the power of technology at it, we will come out with new models and new designs. Maybe it is not efficient. Nature is very efficient, actually. And that's why the pollution is an issue today, because we figured out how to go faster and faster using fuel and things like that, but we are polluting the world. But we figure out how to do it better. It's estimated that a search query that you type in probably burns more fuel than going from place A to place B using a car. Right? We don't realize that the pollution that we create is significantly higher because we are using computers to do the search and things like that. But that's how we do things actually. And a network of machines tomorrow, if you think about the whole internet connected machines, computers as a network can actually be more intelligent than humans. It definitely remembers more things than humans because all knowledge is now residing in the internet. It can do things faster than humans. And it also can recognize faces more than humans, right? The advantage of a computer is that it can remember a billion faces, provided you feed it in, and it will not make a mistake, less mistakes than humans actually. So over time, I believe that machines, a network of machines, can be more intelligent than humans, quote unquote intelligent. Now, of course, there are questions related to what is consciousness, what exactly is intelligence or compassion and things like that, the emotions around it, etc. Of course, there are now people who believe that computers can have emotions and things like that. So this is a stunning discovery, I believe, of protein folding, right? The DeepMind AlphaFold program, the AI program, has solved the 50-year-old challenge of protein structures to about 90% accuracy, and it will only now improve. And the green is the experimental result, and the blue is the computational prediction, and you can see that how close they are to each other. Now, why is this important? It opens a vast field immediately, right? Because we have now the ability to create genetic code in the laboratory. That's actually easy. DNA is actually easy. What was not solved is how that DNA and the RNA combine together to create proteins, and these proteins are the thing that is inside every living being, plants, animals, everything is built up of these proteins actually. And if we are now able to figure out in the laboratory how to create proteins that can actually, so we have in nature proteins that can take nitrogen and put it into the soil. We have proteins that absorb carbon and create carbohydrates. Now imagine a world, and viruses are all proteins only, right? Now imagine a world where we can create these proteins in the lab. So can we create a protein that will actually absorb nitrogen in the lab, nitrogen from the atmosphere or carbon from the atmosphere? These are possibilities. This can happen probably in the next 20, 30 years. The other thing is, this is at the intersection of many, many different disciplines of science and technology. There is physics involved, there's chemistry involved, there's biology involved, there's computing involved, there's mathematics involved, so many fields actually. And that's where we are going in the future. And this is the world the students today, the youth today are inheriting. And this is the world of the fourth industrial revolution. I strongly believe that, it will be science fiction. When we look back 30 years from now, it is science fiction when we look back 30 years back. I still remember in the early 90s, no internet, no social media, no mobile phone, and probably the youth today must be wondering, what ancient world we were living, right? But, we were able to create today's world. Now you're going to create tomorrow's world built on such technologies and things like that, at the intersection of computing, at the intersection of AI and developments in biology, physics, chemistry, etc. And that's what makes it very exciting. IoT revolution I already talked about, but the most important thing is the data that we are going to generate. And it is estimated that every year now we are creating all the data that was there till now. That's the explosive growth of data. It's doubling almost every year, and it will accelerate further. Implications of these are many actually. Of course, the volume of data is many, too much. Again, we need new tools to understand what that data means and how to use that data. Again, that's why I come back to machine learning, deep learning, etc. Because unless we have a tool like that, we will not be able to learn, understand this data and what it implies, etc. Most of the data is actually not formatted in a way in which normally a computer would be understanding this. It's all textual, voice, video, etc. And we need now new techniques to actually use and leverage and manipulate this data, etc. And of course, there are the downsides of this data, which is fake news. And 27% of the respondents actually said that data was inaccurate, actually, right? So it will only increase in the future, because just as you manipulate things, you can manipulate now data also. So you can actually, manipulate an image to show somebody else there, manipulate a video to show somebody else there, etc. Plant a voice into a video and things like that. So there are lots and lots of challenges, but there are significant opportunities also, and the velocity is increasing in everything that we do. Every endeavor that we embark on throws up now huge amount of data in our world, and we need to understand how to use this data, how to leverage this data, how to manipulate this data and use it properly. And that's true for research also, right? Let's take a healthcare example. As a human being with a wearable device and multiple wearable devices, we will be throwing up petabytes of data. Our DNA sequencing, which is unique to each individual, will throw about so much data. Our brain signals will throw out so much data. There is an experiment where now, if you can unconsciously imagine something, most of us have imagination, right? And we can imagine something happening in our mind. And that's how, when I now prepare myself for this lecture, what do? In my mind, I actually run through what I need to say, right? Now, that means I'm rehearsing. Now, can you capture that thought and document it? It's possible. In the lab now, they're starting to do that, actually. So, all these are what drives the fourth industrial revolution, what is possible, what are the opportunities for science, for engineering, for technology, and for entrepreneurship and things like that, for creating this new world. And that's what I believe very important. So from there, if we shift to now economy, every industry will get impacted. Startups will emerge with new business models and solutions. Some large companies will fail, but new leadership will emerge. And every industry sector, healthcare, media, entertainment, financial services, the hospitality industry, retail industry, manufacturing, transportation, every one of those industries are going to be changed. Some directly using this technology, some indirectly, because the business models themselves will change. How we do things will change. And that's what is important. See, when I look back at the IT industry, what is the traditional model of developing software? All of us sit together in a room and develop it. We shifted that work to India, right? We said leveraging technology, we can actually shift that work. Shifting work is a business model change. And when we work from home, we have all shifted the model of working, right? So business model is equally important, because the way we do things has to change also. And that is why the change in technology will result in changing our life, changing business models, bringing in new industries, new opportunities, new leadership, and new leadership as a country also. And that's the opportunity that we have. Can we make 21st century India's century? 20th century, US transformed itself, became the largest economy in the world. Can we, leveraging science, technology, research, innovation, entrepreneurship, transform India to become the world's leader. And I believe it is possible. In small areas, we have done that actually. In two-wheelers, India is the largest manufacturer in the world. Vaccines, 70% of the vaccines are manufactured in India. Generic drugs, we are the capital for the world. IT services, we are at the top of the world. We have become the third best location for startups, right? One by one, we are trying to conquer areas, and I believe it can be done. Definitely in biotech, I believe we can do this. It will be driven by research. And that's why science is important, scientists are important. The more you know you don't know. And that's why research is fascinating, actually. And I'm going to conclude by sharing something I saw in NBC News. And this is what is fascinating. And this is what I actually spend all my time reading up things where there are still unanswered questions, and there's a big questions in physics. Why is gravity so weird, actually, bending of forces and things like that? Why does time seem to flow only in one direction? Everything in physics is two-directional and multi-directional, but why time is only in one direction? Where did all the antimatter go? What happens in the gray zone between solid and liquid? But most important, how did life evolve from non-living matter? Right? And we are now starting to learn that with protein folding. I think we will be able to evolve life from non-living matter and create anything that we want. And imagine this, actually. We said we want to compete with nature. We don't need nature anymore. We don't need nature anymore. We can create life. We can engineer life. We can do anything we want in the future. Now, will this happen in 30 years? Will this happen in 50 years? I do not know. But it is actually in the hands of the students. People hearing here, these students who are around 20, 25, etc. In your hands, actually, to create this world of almost like science fiction. Actually, we will be able to create this world where maybe we don't need nature. Maybe intelligence will be created in the laboratory. Life will be created in the laboratory. And there's so many other questions that we need to understand and answer, but I believe many of these questions will get answered sooner than later, leveraging the tools that we have in our hands. And the acceleration is, it's amazing, actually, the exponential growth that we have seen in the last 50 to 70 years, actually. Exponential growth, and that speed is only increasing. And that's the reason why the fourth industrial revolution has multiple technologies that are all converging to create new world. Right? Think about this, actually. You actually understand the DNA, you actually look at the RNA sequence, you create the code of life, you actually create the protein, design the protein, and 3D print it. Right? At a remote location where it's required. And that's the possibility. 3D printing everything that you want in the future. So let me conclude. If the last 30 years were fascinating, the next 30 years are going to be even more fascinating with the technologies that are emerging. I believe that scientists will play an important role in creating this world. Science will play an important role in creating this world. And my dream is that, scientists in India must play that role. We can do that, and we should do that. It's not a question of money. All these things are becoming cheaper and cheaper. So we will have all the technology that we need, or we will create the technology that we need. We must have the determination, the discipline, and the courage to dream big and make this indeed happen. Thank you all very much for giving me this opportunity to share my thoughts with you. And I hope that all of you will play an important role in creating the India of 21st century. Thank you very much.
Thank you. Thank you, sir. So before going to the interaction, I would like to apologize the registered participants that I am receiving a lot of mail that they could not join because of technical issues. Only the Google limited to 100 participants. Now the platform is open for discussion. You can directly interact.
Yeah, you can ask, if you have any question, you can ask. Any comments, any thoughts, you're welcome. I've shared my thoughts. It's a mix of science, but and experiences where I'm actually projecting it forward. I strongly feel that we can do it, and we must do it.
So can I ask a question?
Yeah, please.
Yeah, good morning, sir. I'm a PhD student from University of Mumbai, and thank you for such an inspiring talk. So my question is, how do you look at applied sciences in India, and what we need to do to make that connection, that the way research is happening in applied science, and how to connect that with industry, and how that will contribute to fourth industrial technology revolution?
See, it's a very important question. A lot of the research today is funded by government in India primarily. But if you look at places like US, Korea, etc., about 50% of the research is funded by industry and 50% by government. The 50% funded by research is typically applied research that can actually result in a product or a service, let's say 3 to 5 years, because industry requires to show linkage between their investment and return from that investment. So the funding for basic research primarily comes from government or philanthropy. Now in India, the industry's involvement in research is very low. And I've been telling my colleagues in industry that they need to invest a lot more into research. I have, I'm walking the talk by myself personally investing some money into research, but I'm telling industry to do that, and I see that it will happen. That's why the pharma industry in India is leading. So they have been investing in research. They're working with the CSIR labs, and if you look at the Department of Biotechnology, they do a lot more applied support for a lot more applied research than Department of Science and Technology. Don't quote me here, or if you quote also, it's okay. But I feel that Department of Biotechnology is investing a lot more into applied research. That's required, and that's the linkage between industry and research. We need industry to come forward and support applied research in a bigger way, and then government and philanthropy supports the basic research, much long-term, open-ended. You don't know whether you will get a results or not.
Thank you, sir.
Thank you, sir.
Can I ask a question?
Mohandas, sir, please.
Yeah.
Sir, it was a well-articulated lecture. I'm very happy to listen to you, sir. One of the major components projected in fourth industrial revolution is matter. You have aptly described it. When we are looking for making everything artificial, you will be able to do wonders creating artificial life. But will we be able to make an artificial nature, artificial life? Is it that it should be looked that way, or maybe that biotechnology for saving the humankind, especially by creating newer vaccines or newer medicines, which could do away with all these unwanted diseases that is cropping up every day? What would be your, because artificial, you talk of artificial every time, See, it creates some confusion that should we look into artificial creation of life,
Right.
or maybe we should. That's okay. Yes.
See, there are multiple questions in what you are asking, right? There is a question of how do we mimic nature, and it will not be the same way nature does things. Nature, for example, flying, right? It has birds which flap wings. When we copied that, we didn't create a plane with flapping wings. We figured out that engineering tells us that fixed wings is what is important. We need to put in a propeller or a jet engine which will push the plane forward. So we used physics and engineering to figure out how to simulate that, right? When we it's very fascinating. I look at computing for everything that I want to give examples for. If you look at the arithmetic logic unit in a computer, I don't think we have in our brain an arithmetic logic unit which is there in the digital computer, because digital computer is actually throwing brute force at the problem to solve the problem. In our mind, probably we have 2 + 2 is 4 in a storage location. When 2 and 2 comes, something else lights up and says 4 is the answer. So it's a pattern recognition that and a memory location that probably has the answer for that, right? And then when the numbers become large, we know how to do it, which is very different from how the machine does it. Machine converts it into binary, and you have logic gates and things like that, AND gates, NAND gates, all that. We have completely done it differently, but we arrived at the solution, and that's what happens, right? So when I say we mimic nature, it is not necessary that we will do it exactly the way nature does. Now, coming to a question about life forms, etc., I think over time, there are lots of things we have not understood. Protein folding, which is a very, very important problem, because we know what it consists of, but we don't know how it happens still, right? How does a chemical, it's ultimately chemicals, atoms, etc., but how does it actually do the work that life needs to do to create carbohydrates or fix nitrogen or kill a germ or create a virus and things like that, right? But that's why I said, protein folding, if we are able to understand, that's a fundamental thing that we are going to leverage. And this will be a technology, I believe, which is going to be high risk and high value. And this will be protected by all governments now. Everybody is going to actually look at this and protect, because imagine this, you can now theoretically create a virus which does everything, a living being which does everything, carbon capture to create a COVID-19 virus in the lab very easily now, just like 3D printing. So anyway, the ethics around it, the technology around it, will it look the same? All of these questions are today unanswered. The data till now says that when we mimic nature, we don't exactly replicate nature. We find a way to do this, and sometimes we find a way to do this much better, but we do it differently. But over time, I think we will figure out how to do it just like nature is doing.
Okay, sir. Now, request P.N. Rangarajan, you can ask. Rangarajan. Rangarajan, please unmute. Please unmute. Oh, yes.
Can you hear me, sir?
Yes,
yes.
Yes.
Sir.
Yeah.
I differ from your assertion that in 30 to 50 years, we don't need nature. Sir, there is a huge controversy that is going on about the origin of the life, and Professor Lee Cronin of UK and Dr. James Tour of US, they argue it on origin of life. And James Tour argues that he challenges Professor Lee Cronin. You create one ordinary, simple bacteria, a single-celled animal. Then I will give up everything. So kindly see that, sir. Protein folding is definitely an important one. I do understand. It is once again a mathematical concept, but to take it to proper science and to the biology is something different, sir.
See, I do not completely agree. I don't know whether it will happen in 30 years or 50 years or 100 years, but the direction is very clear to me. Just look at the mRNA vaccine. Okay?
Yeah.
It is a vaccine where you created the signature of the virus in the lab. Okay, there is nothing in that which is living or taken from a living being. It's completely artificial. The virus signature has been replicated, the spike protein has been replicated. Well, we are not replicating. The spike protein is actually going to be created in your body. That signature is actually injected in you. The spike protein is created, and then you actually, the immune system learns to kill it. That technology is what so we are starting to do it. I have seen in the laboratory, using stem cells, organoids being created. So early, and these organoids are behaving like a mini brain, or behaving like different parts of the organs and things like 3D printing organs, etc. is happening, and putting it back into human. So you are seeing these things starting to happen, and at one point it will all converge, create life forms. May not exactly look like life forms, I and you, but I don't know, but it will actually show all the characteristics of life forms.
Okay,
that's what I mean by this.
Okay, sir.
Thank you,
sir.
Thank you.
Girish, now you can ask.
Hello, sir. Good afternoon. Thank you so much for excellent talk. I am working in the field of material science related to MEM register research, which is considered as a fourth fundamental part of circuit elements. So regarding that, memory devices are commonly used as to mimic the synaptic behavior of our body. So how can we use a sustainable way, or how can we develop the sustainable way in order to use that in a brain or in a biological species? Is there any possibility for that?
So I will not be able to exactly answer you, but definitely that's one direction in which the field is moving in terms of creating AI machines. Right today, as I said, the amount of computing that is required to do a search or do things like this, protein folding, etc., will burn more electricity than we can imagine. It's estimated that if you want to build a computer which is as powerful as a human brain, it will take 300 megawatts of power. It will consume 300 megawatts of power. That's just one brain. Okay, and even then it probably will not be as powerful as the human brain, but human brain consumes 20 watts of power. So see, in nature nothing is wasted. Nature over billions of years have found the most efficient way of doing things, and it's completely self-contained in the sense that it has found a way to generate carbohydrates and proteins and things like that. We consume those things, and we then human beings are there, right, and living beings are there. So it's completely a closed circuit, whereas we have to figure these things out. When we replicate nature, we pollute. When we moving from place A to place B, right, we pollute, right? So we have to figure out an efficient way, otherwise it's not sustainable. That's the difference between what nature has been able to accomplish and human beings are accomplishing. We are not created a sustainable way of replicating nature, but we learn from nature and we'll become better and better over time. That's my answer. Memory stir, as you said, is an element that is being tested to create AI circuits and things like that to mimic learning machines.
Yes, thank you.
Prabhakar. Prabhakar. No.
So good afternoon, sir.
Yes.
Yes, yes, you can ask.
So is that artificial life we are creating in the near future can compete with the natural life which is existed?
Yeah, we are competing already, and we are, that's why I said we are far exceeding physical life in many things that we do through artificial life and through artificial things that we create, right? And that's the destructive power of human inventions, etc. And that's the downside, and that's why ethics is important. What we should do and what we should not do, etc., has to be discussed, debated, etc. And that is definitely a challenge. The whole issue of climate change, sustainability, pollution, all of these are human created issues and challenges, right? And so when we replicate nature, we actually overdo it in some sense. We use excess resources to do that, and that excess resource comes back to haunt us.
Thank you, sir. Thanks a lot, sir. Very nice session, sir. Thank you.
Vishnu.
Sir, I would like to ask two questions. One is related to startup. We have seen a lot of software-related startups coming forward, and they are finding its way. But the story is different for hardware-related startups. So, what are we lacking related to hardware-related startups? Is it the exposure, or knowledge, or focus? This is my first question.
What is the second question?
The second question is about ubiquitous computing. When right now itself in the normal internet connectivities, we are facing issues related to data security and privacy, and we haven't completely found a solution to this. So at a time like this, we are going for this Industry 4.0, where we are going to connect more intelligent systems again together. So how do we promise data security and privacy at that level?
Okay, so on the first question, it's not about capability, it's not about smartness or intelligence, it is about market access, the investment that's required, etc. We are still a poor country. Per capita income is $2,000. Our GDP is about $2.7 trillion, and government has to direct its energy, its resources to solve basic problems of food, job creation, basic needs of people, etc. Right? Food, shelter, clothing, things like that, and that's why the money spent on other things are less, including creating a fab lab or things like that. Private sector will come forward when they see market, etc. If they can get it cheaper elsewhere, they will source it from there, right? So we need to look at the economics around these things, and the economics around hardware in India is coming. We are starting to manufacture mobile phones. Slowly there will be backward integration to create ICs and things like that. It will start to happen at some point of time, and somebody will make the investment required. Your second question on ubiquitous connectivity, data security, yes, it's a huge issue, but that's a global issue. It's not just in India. It's a global issue. Even in advanced economies, when work from home started, people working with their hands, manual work, still working in factories, or let's say serving food in a restaurant, etc., they lost jobs, right? So that problem still exists, and the issue of security, fake news on connectivity also exists in all economies, and that's a challenge that we need to figure out how to address, how to solve, you know, the ability to trust something, trustworthy computing. These are all issues that we need to be solved. Now, I believe that some of the answers will again come from using tools like machine learning, AI, etc., where we can use the machine itself to identify, understand, and fight security issues, etc. So again, I believe the technology that's going to be very important is AI, machine learning, deep learning, etc.
Thank you, sir. Professor Gopchandran.
Sir, I have a question. Two questions. One about starting neural network solutions for chemical products, synthesizing chemical products. Second question is your comment if we start 3D printing technology development in the Department of Optoelectronics. And the last question is a general question about our university. What is your opinion about starting a new department on brain sciences in our university?
So, neural network, I think neural networks are a way to, so they are the building blocks for deep learning solutions. So I think we need to see, just like programming became a required course in all disciplines at undergraduate level, and sometimes now in school, and even in primary school, we need to start thinking about introducing AI, machine learning, deep learning courses, neural network courses in undergraduate or maybe in schools themselves, because it's a fundamental piece of technology that we are going to use in everything that we do, even in chemical engineering or any other engineering discipline, any other discipline, biology, any aspect of science, economics, everything will use deep learning, machine learning. These are tools to look at data, manipulating data to automate tasks and things like that. About 3D printing, again, I strongly feel that this is a technology that's going to evolve, and we need to create the capability to understand and leverage and use this technology. It's again probably not as fundamental as machine learning, but it's still an important technology that we need to learn in different, all aspects of engineering. Sometimes in biology, we will have to look at 3D printing, etc. Whereas I said that machine learning will be required in economics and arts, etc. I can't think of 3D printing being a required course in economics or arts or something like that. And whether the university should create a brain sciences department, I think so. There are two sides of brain sciences which are important. One is about understanding the brain and creating new models of computing. That's where deep learning, etc. came. So we need to definitely invest in that side of the brains, computing and brain. Even the original idea of computing came from us wondering about our brain. If you go back and look at von Neumann and Boolean algebra, the evolution of these two came from people wondering about how brain works, right? I think George Boole thought that our brain is actually a Boolean computer because we have logic. We think in logic and things like that. And so he came out with this discipline of mathematics, Boolean algebra, and that's the basis for computing. Similarly, von Neumann said our brain must be organized in separate areas, where some places there is a place to store, some places there's a place to actually think about logic and things like that. Algorithms are in a different place. And that's how we created the model of, because we started thinking about how does brain, think, and that's how we created the model of computing. So us wondering about how brain works is how computing evolved, and so we must actually have brain sciences as a group within the university. And the second aspect of brain is brain and aging, right? See, we will have 200 million people above the age of 65 in the next 20 years. 200 million people above the age of 65. And about 1 in 5, 1 in 6 will develop some kind of neurological disorder. And typically because of aging-related disorders like Alzheimer's, Parkinson's, dementia, and unfortunately, India is becoming the capital for all kinds of disorders, right? Diabetics capital of the world, hypertension capital of the world, cancer capital of the world, because of the size of the population and the poverty, the illiteracy, etc., that we have, and that the social cost is huge. Same thing will happen now in dementia and aging-related disorders. Out of this 200 million people, so right now it's estimated that 4 million people have Alzheimer's in India. 4 million. Okay, the per person cost per month is 20,000 rupees to manage a Alzheimer's patient. Okay, the medicine and the person to look after that. So imagine the cost, social cost, and the economic cost of managing, let's say, 50 million people with some form of dementia. It will be staggering. And as a poor country, we can't afford it. So we better actually learn. And now what happens if we don't participate? Look at the vaccine issue itself. The top 2 vaccines that the world came up with are not affordable in India, not be used in India. You know, the Pfizer vaccine and the other vaccine they came up with, Moderna vaccine. Both are using special, these are the mRNA vaccines. They're expensive. They need special, technology to transport it and things like that, and they're not affordable. Now, UK, US, etc., Japan are happy because it's not expensive for them. They can afford it. In India, it's not possible. We need our vaccines to come up now. The AstraZeneca vaccine is probably more affordable. Bharat Biotech, more affordable. It uses older technology, proven technology, but it's affordable. So if we don't do this research in India, the solution will not be affordable to us in India. Even now, the solutions are affordable to top 10% or top 1% of the population in the world. For example, in cancer, right? We can now take the immune cells, reprogram them to attack the cancer cells based on the DNA sequencing of the tumor, inject it back, and that will eliminate actually, completely cure certain forms of cancer, right? A course of treatment will cost you $600,000. How many people can afford it? Right? So that is why we must do this research in India. So I completely believe that we need to understand aging and aging-related disorders, neurological disorders. Otherwise, we will all live longer. All of us are going to live longer, right? But what kind of quality of life will we have? What is the cost to society of us living longer? Your own family may think sometimes, why is this person living and being a burden on me and costing me money? Right? And whenever I talk to people, they have actually one example of somebody they know, somebody in their family who's actually suffering some neurological disorder, aging related. I'm talking about aging related. And this is going to be a huge burden. So we need to invest in these things. Otherwise, we'll be dependent on somebody else to solve our problems. And sometimes you can't afford the solution. Okay, I think we need to stop because it's 30. Yes, thank you all very much. I really believe that you are doing all great things. You must continue. You must continue to do well. You must aspire to become the best. So please do, and you can do it. Thank you very much.